Welcome to the talk, Start Your Engines, White Box Monitoring for Your Load Tests. That's the agenda for the next, well, about 50 minutes. Why to use load tests in the first place, then how to set up your test environment. There will be demos and live code, and then some lessons learned from my projects and what to expect. Actually, I do also have some stickers for anybody who wants to get a sticker, either of Grafana or Prometheus after the talk. Just come here and grab one from your notebook or your friends as well, maybe. All right. Good. Well, I'm an IT consultant working at MSG. I'm a developer. I do code, but I also enable teams to actually be productive, to deliver great software. Actually, I've been in the Java world for more than 15 years now. Been doing other programming languages like PL/SQL at some point. I've been working in consumer finance, like web applications where people log in and apply for credit. I've been building an online banking back in the years. I'm married, 2 kids, and do have a hobby, geocaching, like looking for small hidden boxes with very expensive satellites out above of me. And that's a hobby, to get away from computers a bit. All right, but then come back to the agenda. So why to use load tests in the first place? So the naive approach is, well, the developer, he or she, well, it works on his or her machine, and that's fine. But that's what we developers do in the very first place. And then maybe a second developer or QA person tests it, works on that machine as well. And well, then you go to production. Lots of users start using the application. You're successful. But then your server goes up in flames. And you find, well, what happened? Why does it happen? I have no idea. So, well, let's find out what we can do different here. Then the alternative approach would then be what I present today, load testing and monitoring. So again, there's a developer. He or she develops the software, functional-wise. And then, well, the testing is, there are going to be some maybe explorative testing, but then you'd also do some load testing with tools like Gatling or JMeter. And then, you set your server in flames, and then you find out what's going wrong. And what helps you there are metrics. You use a monitoring system. In our case, it's going to be Prometheus. And add as many metrics to your application that you need. And you will learn how to read the metrics from your containers. You learn how to read the metrics from your Java virtual machine. And then once you added all the metrics that you need, your server is no longer on fire. You're able to keep up with the load, and you go to production. And your users are happy. Your server doesn't go up in flames, and all the metrics that you put into your application, they are still there in production as well. And you can use them to monitor your production, to find out how many requests do I serve, are they successful, do I serve errors, what are the response times, and all that is, well, bundled into your application and staged to a production environment. And that's why we want to do this here today. But then crucial is how to set up a test environment for all this. So it's about monitoring, as I said, and well, you have your hosts. It's going to be like virtual hosts, it's going to be physical hosts. They're going to be applications running on them, and they all produce metrics that you want to aggregate. And well, at some point you want to generate alerts. That's also part of monitoring. That's not so very important when you're in a test environment, but it's going to be very important when you then run in production. And well, dashboards. They're important for us, well, developers, to put them on the screens, but they're also important for the business to find out how many people actually consume my services, when there are good times to do maybe maintenance. These are very, very important things that you can put on big screens and screw them on your walls. And while the tool to bring all these 3 things together, that's going to be Prometheus in this talk. Prometheus is a monitoring system. It's a time series database. And we will find out in a minute that it's a bit opinionated. It tries to do certain things very good. But it's there for actually instrumenting your applications, to get the metrics in the first place, to collect them, to store them in a central database, to query all the data, to do alerting, serve the data to dashboards, and also do some, some trending for your data to find out maybe if a disk is going to be full in a short amount of time, that you be alerted before it's going to be full. So some trending is there in there as well. That's Prometheus. So Prometheus values operational system monitoring most. So it's there to tell you the systems that are running there in production now or in a test environment, are they running okay? And it keeps some history about these services, like 4, 6, 8 weeks maybe, but it's not there to keep raw logs. It doesn't care about events. It's not about tracing requests. It doesn't do any magic anomaly detection. It's not for accounting and SLA reporting. It's just there to tell you your systems are running okay. And if they're not running okay, point you to the server that is giving you problems. It's, compared to other monitoring systems, very, very simple to set up. You install one single binary, a Go binary, on a single machine, and that keeps a local storage for some weeks, like 4 weeks, 8 weeks. You choose. And it's so simple to set up that it will be the last thing to fail in a data center. So there's no magic clustering around, so that's give you any headaches. It doesn't support horizontal scaling. There are add-ons that you can use. It doesn't support clustering in a clustering way that there's a failover. It supports you can have 2 master nodes that both pull the data from the same targets and keep them in a high available mode. All the configuration you do is going to be by configuration files. There are going to be no web UI, no user management. But at least to me, that's a good thing. I can check in all the configurations in the Git repository. I can stage them through different environments. And I feel safe that I'm not missing any manual configuration here. Prometheus is almost always about pulling data from processes. So Prometheus will either be configured by you to find out all the things in your infrastructure where to pull the data from, or it will use service discovery that you might already have in place, either by Kubernetes or with Consul or whatever other service you use for service discovery. And then it will pull the data and then ingest the data, puts it in its own database. And the database, well, it's just another NoSQL database. Well, but then it's very optimized for time series data. It will keep them very compact. That you don't need that much of disk space, that you can do fast querying on it. You can actually, the data ingestion, you can massage the data a bit so it fits your need. In the end, it's all going to be multidimensional, and everything is a float 64. So we don't have a data silo in the end. So you can actually combine this data, well, in the way you want in dashboards, as you see in a minute. So that's Prometheus. But let's really build our test environment. So 2 things we definitely need. We need our Java application. Well, we can choose any other application in the end. There are other instrumentation for Prometheus for other languages as well, but today let's stick with Java. And you have your load test. I usually do them either with Gatling or JMeter, and you both deploy them to your test environment. And the load test calls the Java application. And then you set up Prometheus. And Prometheus, well, wants to pull some information about the containers you deploy, about the hosts you deploy, how much RAM do they have, how much CPU usage. All this information is then provided by exporters. And the node exporter exports hosts metrics, and a C advisor exports the metrics about the containers that are running. All their names, the memory usage, all there is about the containers. And these you would usually also run in a production environment because you're interested in these metrics as well. Then you would install another exporter, the Graphite exporter. So that's actually a gateway that can ingest Graphite metrics and then provide them to Grafana to pull them. And then you set up your load test, either Gatling or JMeter, to push the metrics to the Graphite exporter, and then Prometheus can pull the information from the Graphite exporter and puts it in its own database. The last bit of information that's now missing is the information from the application, and then Prometheus will contact the application and pull every 5 or 10 seconds, depends on your setup, how often you need this information. We'll pull this information from the application, also ingest this information and put it into the database of Prometheus. So now you have all the data in Prometheus in one single database, and well, you can query it. You can query it from Grafana. You can build dashboards from this. And this is actually your setup, how to set up your test environment for a load test with containerized applications and Prometheus as a monitoring tool. You've noticed there are now boxes there with 2 different colors, purple and blue. So if you're in a team that provides the infrastructure that enables the product teams to actually do their work, you would probably go out there and install one single Prometheus per environment that goes along with one Grafana instance, and then the Graphite exporter, the C advisor, and the node exporter. So this needs to be done once, probably once per environment. And then the product teams can deploy the application there using whatever container technology you actually want to use here. And this is a self-service infrastructure. That's, well, true DevOps in that way, because they will just use the APIs. They will either configure Prometheus, maybe either adding something to the configuration file so Prometheus can actually find the Java application, or even better, they plug into the service discovery mechanism. So actually, once all the purple boxes are set up, they will not be changed. And then you can have as many teams, product teams deploying their services to this environment. They do the load test, they do the Java applications, and they do their own dashboard. And one dashboard that accompanies each of these load tests. Right. So why Graphite and the Graphite exporter? Well, the good thing is, well, the primary reason is JMeter and Gatling support Graphite metrics out of the box. So you don't need to add anything to these test tools. So you work with the things that you have at hand. And you might also notice, okay, Graphite is a push protocol, and the JMeter and Gatling push their information to the Graphite exporter. And this enables you to run your test on any node you like. You can do some explorative tests on a desktop, and that pushes this information to the Graphite exporter. But then at some point, you probably want to move your load tests that are triggered by your continuous integration server, like Jenkins. So that is going to run Jenkins and then push the information by the Grafana gateway. And it's actually maintenance-free. The Graphite exporter is we don't run Graphite. We just run one Go binary being the Graphite exporter for Prometheus. It gets all the metrics. After 5 minutes, it forgets them. And during that time, Prometheus takes the metrics from the Graphite exporter and puts them in its own database. So it's really maintenance-free. From an infrastructure point of view, it's an ideal piece of software. And well, from the load tests, you export all the things that you usually want to have, like how many users are actually simulated by the load tests, what are the timings that you have, aggregated request timings with percentiles, how many requests went okay, how many failures have there been. So this is all the information you want to know about your load driver. And this is then put into the Prometheus. You find out that, well, the metrics look like long names with underscores. Gatling, my simulation, underscore users, all users done. So it's a hierarchical structure. You can do some configuration to the Go binary to make it a proper Prometheus metric with labels. But on the other hand, it's just a load test. You can start with this out of the box and get some good results. All right, but let's start configuring Prometheus. So in this case, I've chosen to manually configure Prometheus to tell it, this is the IP address, this is the port where it should look for the node metrics, so the node exporter, the metrics of my host. And it's going to scrape this information every 5 seconds. And well, how does it look like? If I go to that port, let's see if the demo works. Yeah, it actually returns a page with lots of metrics. And this is actually the metrics format you will see of Prometheus. You will have a help text here. Actually, well, as this node exporter is a Go binary, it will first export lots of Go metrics. but then only after that it will have some meaningful host metrics. So load CPU. So it's always a help text, a type, and then a counter. And it tells me, okay, about CPU cores, what mode they're in, and I can actually then find out about this. And what is a counter? It's counting up. Once you reboot the machine, the counter will start again at 0, and then count up how much CPU seconds has been it's spent in one single CPU mode. And it's being stored as a multi-dimensional metric within Prometheus. So it's 576.91 seconds that CPU core 1 spent in mode user, and actually the label that we've seen in the page before is also, the metric name is also a label. And Prometheus will add some more context information to that. In my case, it's just the name of the job and the instance. If you're running, for example, in a service discovery mode, it will add all the information that you have in service discovery, like the namespace that you're in, if it's a test environment, if it's a production environment, the name of the pod, whatever what there is, it will add it as context information. The application will not need to know about this, but Prometheus will add all this context for you. But, well, this number of CPU seconds is quite boring. It's always counting up, but humans are interested in other things regarding CPUs. And because all of this is stored in the database, and you can actually calculate on that. So in this very middle, node CPU, there's my metric. You can filter it. You can filter it by mode. You can apply a function to this to calculate the rate of change, how many CPU seconds have been used in a 5-minute interval as a rate, and then find out the inverse of that. So this expression gives me the percentage of a CPU, how much of the CPU core was used. But on a single core, that's quite, well, boring anyway. You're more interested in a host. So how much CPU have you been using for a single host? And you can aggregate it over the instance. And the next thing is, you want to know how much CPU I'm using in my cluster. Then you aggregate by cluster. If you have an A/B test, you can aggregate by A and B and compare these two and say, okay, I'm doing a load test, and on one cluster part, I have 10% less CPU usage. These are the metrics that you're looking for when you're doing CPU using load tests. But then these are host metrics. And then you go up one level looking at your containers. You have CAdvisor, it's a tool from Google, another Go binary. You install it, and it will give you information about your containers. It will actually give you also the names of the containers, so Prometheus kind of discovery them, so you have a list of all the containers running, and you can look at your containers from the outside. How much RAM are they using, how much CPU are they using, and you can do calculations on these as well. So this is being now this is the web front end of Prometheus. This is, well, boring in a way that you can add your expressions in here, and you can look at the current values and graphs, but you can't actually persist anything in here. What you then do, if you want to build dashboards that are actually saved, you go to Grafana and then build dashboards here. So I see here now the CPU usage per container, and so I go to edit mode and I see Grafana. That's the most recent version of Grafana you see here, the syntax highlighting for Prometheus. And I can ask it, okay, CPU usage in user mode in seconds total, and give me that rate of a 60 seconds interval, and group it by container, and then you get graphs. So I see, okay, CAdvisor using 5% of my CPU, and other containers are using less. Yeah, my load test is not yet running, but that gives me an impression of a system running no load at all. But now, let's start looking into the applications. So looking at the Java virtual machine from the outside, looking at RAM usage, looking at CPU usage, that doesn't tell you very much. It doesn't tell you what is the RAM being used for, what part of the heap is being used here. And CPU could be either used for garbage collection or for proper user interaction. So you can extract this information, and to do that, you add another library to your Java application, the Java simple client, another jar as a Maven dependency, And well, if you can either add the simple client as it is, the core one, or if you're using Spring Boot, there's an addition to that, so it just hooks into Spring Boot and registers the proper endpoint here. So that's alternative one, and that's quite battle proven, and it gives you all these metrics that you need. So let's go to our Spring Boot application here, and the Spring Boot example I have here, metrics, right? So it gives me JVM metrics with heap and non-heap memory, and it gives me out of the box, if I use the next exporter, also metrics about all the HTTP endpoints, and that's really cool. So the alternative one is, as I said, the Prometheus Java Simple client, add it and use it. Quite recently, and you enable it in a Spring Boot configuration file, class, sorry. Alternative 2 is there's no micrometer.io. At the same time, when Spring 2 has been released, there's been a release of micrometer 1.0 that you can add both to Spring Boot 2, but it's also the backported version available for Spring 1 as well. So you can add these two libraries to your either Maven or Gradle configuration, and then you export them using micrometer.io. But you have a choice to make. Micrometer.io is very good integrated into Spring Boot, and on the other hand, it's quite new. The simple client of Prometheus is quite battle tested, but yeah, it will only give you Prometheus exports, while Micrometer will give you exports for lots of other things as well. You can export your metrics to Elasticsearch. You can export them to very, very many other tools as well, but also to Prometheus. So that's alternative 2 that I follow up in this talk for the rest of the Java part. And as you said, the Java metrics, the Java virtual machine metrics are automatically exported. So they're there with all the heap information. But when you want to drill down to specific application methods, you have components, Java beans, or Spring Beans to be correct, you can add annotations to them and tell it, okay, at this point I want to have how often has this method been called, how much wall clock time has passed. When I use this method, I can also create histograms for that and quantiles. So that's whenever, and I need to actually, at the very current version of Micrometer.io, I have to activate this aspect. I have another Spring Boot configuration that needs to add the aspect, and then I can add one line of code for every metric I want to collect. And well, I have to probably add as many metrics as I need to actually find out how my system works, and until I think my application is properly monitored. And I can put in the value of the metric, the name, and also a description, and that's then being passed on to the endpoint. So when I go in here, so do something, so I find out, okay, how often has this been called, how much time has been passed for all the calls, this is a moving average for second max, and I also have a histogram, like 90% of all calls and 95% of calls are within a given limit. Yeah, because the load test is not running, this is not returning a value currently. Yeah, and that's Micrometer. So we have now collected lots of information. So we looked at the Java virtual machine, we looked into our application functionality, we added some annotations there, but then we have our external interfaces. We had talks today that, well, at some point in the future, we probably have a service mesh that will give us a lot of information about the communication between the services. But something we have today, and that is battle-proven, that's Hystrix in the Java world. And Hystrix is a circuit breaker library. It's a circuit breaker library that will take care that you don't overload other people's services and also provide fallback methods. But internally, to do all that magic that Hystrix does, it collects a lot of information. It collects how often a call to an external service was successful, how often it failed, and also the response times. All this information is there, and you just need to export it to Prometheus as well. How to do that? You add a Hystrix Prometheus metrics publisher and register that with Prometheus simple client, and then it transfers all the metrics. And then you go along with your standard annotations, Hystrix commands in your Spring applications, and you have this information as well. Yeah, and let's do the demo. So what I have with me here is a load test that I can run here. It's actually using Gatling and the number of users that are then being processed here. And I can go to my dashboard. And now let's see, okay, the number of users that have been processed, this is the number of completed users, is now increasing over time. I see that the CPU usage is increasing. I see that my Java collection is doing some work, but still below 1%. So that's fine. So my application is doing something meaningful. I can have a look at the Java memory usage. So this is basically the idle graph of a Java memory usage. And now I can look into all the memory graphs. I have now this at timed annotation. I've chosen just to have the average duration in here. And now I also have this Hystrix information in here. So it's telling me, okay, some of the operations have been successful, like 70, just between 60 and 70 operations per second are successful. 15, 16 operations per second are not successful in my test here. And all this information is there for me to read during my load tests. But as I said, all this information will also be available during my production environment. And I also have, with Hystrix especially, all this percentiles. How long was this request? Not only on average, 50% histogram, but also like 95% of all calls completed within, 231 milliseconds, and the 99 percentile. Everything else can be calculated from the message that you get. Sorry. Actually, Prometheus is collecting this information in buckets. So you actually first collect the data, and then afterwards aggregate this data over your cluster. So you have an aggregation. So yeah, usually if you pre-calculate your quantiles in your application, you can't aggregate them in a cluster. If you put this information into buckets, you can later aggregate that in Prometheus. Right. So this is the backup for the demo. Good thing that the demo worked. All right. But then, what to expect if you do something like this in a real project? So what I've seen, people look first at CPU usage per container and RAM usage per container. That's interesting, but you have to dig deeper than that to find out where your bottlenecks are. The standard Java runtime metrics give you information where to look at, if it's a Java collection, if there's any memory pool that need to be increased or probably decreased. You look into the counters because they're easy to deal with. You have gauges that, for example, for a database connection pool to find out if it's exhausted. Do you have errors when getting connections out of the connection pool? And well, for some of the applications that we're monitoring, we actually use drop wizard metrics because it was integrated already. For this, there's also a gateway to publish drop wizard metrics to Prometheus. So it's very nice. And especially this timing information from the Hystrix library helped us a lot. So what helped us a lot was then we had all the load test metrics, the inter-application communication in one database in Prometheus to correlate this. So this dashboard you've seen here gives us the idea what is happening in the different parts of the system in parallel. But you can also actually put all these graphs in one single graph, so you are overlaid even better. But that depends on the questions that you want to ask your system, why it's behaving this way or the other way. And it was really self-service. Once the first building blocks were in place, the exporters, the product teams were really productive and could do their job without interacting with a human in the platform team. But then, a good thing that you probably want to look into is, well, the metrics that you export, there's a naming convention if you're using Prometheus. For example, everything that is a counter should be recognizable as a counter. If you count seconds, then you should have a metric that is named seconds. You always should collect base metrics, so you shouldn't in one place count milliseconds, and the other place then counting seconds. So yeah, there's some naming conventions that you probably want to follow if you want to have meaningful metrics later on in production system. Well, if you fall back in some scenario to use job wizard metrics, you find out that you will not have this help texts that we've seen. If you use Prometheus directly, Prometheus simple client, or if you use micrometer.io, you can provide all these help texts. If you're using job wizard metrics, sadly there are going to be none because there's no place in the API for that. At some point you will also find out about, well, counters and averages. Counters are very easy to aggregate in a cluster because then you just sum them up. But if you pre-calculate averages in your cluster, you can't sum them up afterwards. Also, histograms, how to summarize these, and percentiles. Yeah, you have to make up your mind. You maybe, if you then want to introduce Prometheus and this kind of monitoring to your organization, you probably want to look at a very good prototype that explains these things a bit. But on the other hand, try not to make it too complicated for the product teams to do their work. Otherwise, you might not have any metrics in the end. And some further reading here, there's some acronyms here, use and read. So, for example, that gives you an idea when you have, for example, a database connection pool that you want to, what are the things you're most interested in? Utilization would mean how many database connections are active. Saturation would mean I want to find out what's the percentage of all my database connections that are at maximum in the pool are being used. So I make it in closer to probably maximum here. And how many errors did I have? And for each resource that you're trying to monitor, you can use these acronyms to make sure that you have a consistent monitoring in place for all the different things that you want to look at. So what I found in my previous project, well, it's FrantiTech. You can run Prometheus on a local desktop, so you can download a binary for your Windows, for your macOS, for your Linux desktop, and give it a short try to find out if the metrics that you're exporting in your development out are actually meaningful. And when you then roll it out, well, you could say, well, at least one Prometheus for each environment. So if you have a production environment, you will have an own Prometheus for the production environment. And if you're a testing environment, you have one Prometheus for each test environment. You might even end up in a situation where you want to have one Prometheus for each team, so they can configure it the way they want. They can configure what metrics to ingest, how long to keep them, and that makes your teams even more independent of each other. Yeah. It's also code and continuous delivery friendly. So all the configurations, there are YAML files and stored in the Git and deployed throughout all the stages. Well, except for the dashboards. They are actually point and click. But you actually export the dashboard. You could actually export the dashboards from Grafana web interface as a JSON and then put that JSON into a Git repository and then use it for automatic staging. The most recent version of Grafana, the version 5, provided great support that you can put these exported JSON files into a separate folder, and they're going to be read automatically when Grafana starts and being served. So it's very easy now with version 5 to do that also continuous delivery friendly. Right. So and then having everything in a configuration in a Git repository, for example, it makes it easy to test things locally and actually make it easy to stage them between the environments. As I said, simple tablet, it's Go binaries. You actually can run them without a Docker container, but you still put them in Docker container if that's easier for you to distribute it to your containerized environment. You can put Prometheus in a Docker container. You can put in also the node export into the Docker container. CAdvisor works in a Docker container as well. So that's really nice. Today, I've shown, well, how this works with Java processes. There's also very, very good support for Go, because well, most of the things we've seen here today, the tools, have been written in Go. There are other client libraries for other programming languages, but on the other hand, well, it's a text format. It's not even JSON. So it's just about writing out the label, the metric name, giving it some labels, and a number. So this can be done in any programming language, even if your programming languages are not on the list today. There are also ready-to-use exporters for commercial tools that you find around and open source tools. For example, if you're running a MySQL database and want to get metrics from a MySQL database, there's a MySQL exporter. And if you're running Postgres, well, there's a Postgres exporter. So you see a pattern there. So then this gives you then the visibility of your infrastructure. All right. So this is now a list of links, and again, my Twitter handle. I will post the slides of today on Twitter. So we've seen Prometheus, we've seen a Java Simple Client. Yeah, actually, full disclosure now, the Prometheus, Hystrix, Metrix publisher, I took over maintenance for that library. So I'm a co-maintainer. Yeah, and all the other tools you've seen here today. Well, thank you very much for listening. Thank you. And I think we do have time for questions, right?
Hi, thanks for the talk. Do you have any ideas, or do you encounter any major problems? What can you do wrong with if you do use tools like Gatling or JMeter, and then you produce some results? And what are there any major mistakes one can make? And then looking at the data and seeing the wrong things, or do I encounter anything like that? Or is what should I look for if I want to do something like that? Is there any major thing I should avoid, or do you have any experience with that?
Well, one thing you might. Yeah, well, first you need to decide about the tools, JMeter or Gatling. That's probably one choice you want to make. JMeter produces you an XML blob, but you have a point-and-click interface, and it gives you some metrics already in the interface. With Gatling, you need to learn a bit of Scala. Right. At some point, we will doing some more complex scripting in our load tests, and that's one point we decided for doing it with Gatling and Scala, and that some proper code we can check in. And we were able to produce all the load that we needed with one single instance, because it's not using threads and and doing a very good job here. Also, it creates an HTML report at the very end, and if you run it on Jenkins, you can archive it. Well, when you're doing these kind of load tests, what very, very seldomly happens is that your load tests run, everything is fine, and then it breaks in production. Well, at least if you have a right amount of load that you're creating. So most of the time when you use these tools, you're actually looking, why is something broken? And to get visibility of tools, you probably also want to look into how to ship your logs to a central Elasticsearch, Graylog, whatever. But also at a tool maybe like Zipkin to find out where are the latencies in there. And these are tools that you probably want to have as well to ease your work when you're actually looking for problems in there. That's maybe a bit of an answer. Well, okay.
One question regarding end-to-end analysis of a.
Right.
So I think you have here a good approach to see something of your system utilization, things like that. But if you have to analyze what happens when a user has a bad response time, and you have to know what happens in the database, what happens on the web server layer, things like that.
Well, so what we've seen here, well, I've had only one single Java application as an example. What we actually tested was a system that consisted of lots of microservices with interfaces in between, and that worked quite well because we also had these connections between the microservices instrumented with Hystrix, and we saw that very well. There's also an add-on for the MySQL, maybe for all JDBC connections, but maybe even only for MySQL, I'm not sure, 100%, that you can get also the timings of the database. So you get percentiles of database response queries, depending on the query that you send to the database. So you get some visibility there as well. But you get, well, average or percentiles visibility there. You don't get visibility for a single user. And if you want to get visibility for a single user, there's been a talk today about tracing, especially Zipkin. And Zipkin gives you then a call tree for a single user and how that response time divides throughout your system to the different parts of the system. But usually, especially maybe when you want to run a load test, with Zipkin or other tracing tools, you will trace only a percentage of your calls, like 1% or 0.1%. But with then you have some traces. If you have like slow traces, then there's a given probability that at some point you will trace also that one slow call. But on the other hand, with Prometheus and all these counters, you will count 100%. So you know if you will then be in a situation where you have a Prometheus report saying there has been a slow call, but if you're tracing only 0.1%, you might not have that trace in there. So that's the situation you might come into.
Hey, you mentioned that you only have one instance of Prometheus or should have. So is there limits when you have like a big data center with a lot of VMs, and how to do this?
So I said there should be like one instance per test environment. So it depends on how you split your system to different Prometheus or different environments. But then Prometheus is very efficient in ingesting this data. So we can have millions of metrics that you ingest there and put it very efficiently on a single Prometheus node. If you then have multiple data centers, you can build a hierarchy of Prometheus servers that is then aggregating this information. And you can either build a dashboard from the single Prometheus that you have in different data centers, as Grafana can connect to different Prometheus, or you can aggregate the data to one single instance of Prometheus and then do a Grafana dashboard on the very top of the pyramid. And then there are other tools that for example, you can stream this information from Prometheus to an InfluxDB, that you can have really scalable data storage for that, and there are now other commercial offerings coming up to do, store lots and lots of data, multi-tenant, whatever, with Prometheus. Yeah.
Okay, thank you very much, Alexander.
Yeah, thank you very much.